Let's go ahead and do number 7. Distribution has the following quartile points. So Q1, 16.2, Q2, 44.3, Q3, 65.4. Which of the following is false? So it looks like we got quartile deviation, interquartile deviation, stuff about percentages of the sets. Now, anytime you're dealing with quartile deviation, okay, quartile deviation, what it does is it breaks your set up into 4 parts. Okay, and that's 3 parts. There you go. So first part, second, third, and fourth. There we go. Now this would be Q1, this would be Q2, this would be Q3, and then these would just be your max, and this would be your min value. Anyways, your quartile deviation is the distance between these endpoints here. So quartile deviation would be the distance between Q1 and Q2, which is also the distance between Q2 and Q3, Q3 and the end. Because what the quartile deviation does is it divides your set into 4 equal parts. Okay. So again, the quartile deviation, by definition, okay, so quartile deviation, by definition, is Q3 minus Q1 all over 2. Now that should make sense if you took Q3 minus Q1, that would be the distance between these two. Well, if you divide it by 2, it cuts it right in half, meaning it's the distance between Q2 and Q3. Okay. Alright, so then let's go ahead and see which ones work. Quartile deviation, they're actually saying, is the value 24.6? Let's go ahead and find out. Q3 was 65.4, and Q1 is 16.2. And we're going to divide that by 2. So go to your calculator. Type all that in. I get 24.6. Great, because that's exactly what the quartile deviation is. So A is true. Interquartile range. Interquartile range, I'll write that over here. Interquartile range, we'll do IQR. Interquartile range is just Q3 minus Q1. Well, that's 65.4 minus 16.2, and if you do that, you get 49.2. Well, that's exactly what B is. So that's true. 50% of the data is above 49.2. Okay, well, 50% of the data, well, the way quartile deviations work is 50% of the data is between Q1 and Q3. 50% of the data is below Q2, right? Because that's 50%. This is 50%. Okay. So actually, 50%, which is all this, and I'm really making a mess of this. This is 44.3. Okay. Where's 49.2? Well, that's like right here somewhere. And 50% of the data is not above 49.2. 50% of the data is above 44.3. This is definitely false. Now, what they're trying to do here is they're trying to trick you in that we know 49.2, that's a number from the problem. I mean, it represents the interquartile range. What the writer of this question is trying to do is to see if you understood the difference between a number and a set, like 16.2, 44.3. These are numbers in the sets. Well, actually, may not. Now, let's pretend they are, okay, for the sake of this problem. These are numbers in the set. 49.2 is just the distance between Q1 and Q3. That actually has nothing to do with data values in the set. Okay. So F is going to, or C is going to be false. Now let's just see if anything else makes sense. 25% of the data is below 16.2. Well, here's 16.2. And 25% of the data is below it, which is exactly what this is. The distance between the bottom, the min, and Q1, that's 25%. Because, this is 25%, here's another 25, another 25. D is definitely true. Approximately 50% of the data is between 16.2 and 65.3. Sorry, 65.4. Well, you know what? 65.4 is Q3, and 50% of the data should fall between Q1 and Q3 because that's how quartile deviation works. And so E is also true. So it looks like our only false is C, and so the answer to question 7 is C.